Hello friend, I Dr. Mohanil Verma from Department of Applied Physics, Sri Shankaracharya Technical Campus, Bhilai. Welcome you all in this lecture number 10.4 from the unit 10. The title of this lecture is Solid State Laser, and in this lectures I will include the structure and working principle of Ruby laser, and this is the part of SysB2 Physics. Learn with me, lecture on some special topics. So outlines of this lecture, objectives and prerequisite, different types of laser, and then the introduction of Ruby laser, basic components of laser, and structure of Ruby laser in detail, Ruby laser working principles, and Ruby laser limitations in its applications, and finally the summary of this lecture. So objectives and prerequisite. The objective of this lecture is to discuss the construction and the working principle of Ruby laser along with some important applications. As a prerequisite for this lecture, I expect from my students that they should have the knowledge of fundamental mechanism of laser, three-level pumping systems, schemes, and basic components of lasers. The different types of lasers in general on the basis of the material of active system, active material, that lasers have been classified into three main parts. One is the solid state laser, and these solid state laser are further classified into two: the Ruby laser, which is actually being discussed in detail in this lecture, and second one is the NdArc laser, and second is the gaseous laser. And there are two types of laser in gaseous shape, like carbon dioxide laser and helium laser. So, and the semiconducting laser, in the semiconductor laser, gallium arsenide and gallium phosphorus arsenide is considered. So Ruby laser, an introduction. The Ruby laser is the first type of laser actually constructed and first demonstrated by T.H. Maimon in 1960. In this laser, ruby minerals, which is also known as corundum, the ruby crystal is used. So the ruby crystal is actually the combination of aluminum oxide Al2O3, which is also known as alumina, in which the small amount of chromium oxide, that is the chromium ions in only 0.05% is mixed, which gives its characteristic pink or red color. The Ruby laser is used as a pulse laser, producing red light at the wavelength of that red light is monochromatic, and that is 6943 angstrom. After receiving a pumping flash from the flash tube, the laser light emerges for as long as the excited atom persists in the ruby rod, which is typically about 1 millisecond. So the basic components of laser, so we have discussed in our previous lectures. So these are the basic components of laser. In a laser system, there must be one active center, active medium, and pumping technique to pump atoms from one energy level to another energy level. Optical cavity, that is the resonator and pumping scheme. As far as that Ruby laser is concerned, the active centers in this laser is the chromium ions, active medium, that alumina, which is actually a transparent crystal, and in form of powder, this is a shining white powder. And pumping techniques in this laser, xenon or radon flash tube is used as a pumping technique to pump atoms, that ions from one energy level to another energy level. And obviously that optical cavity, that Fabry-Perot resonator, is the crucial part of a laser system. And the pumping scheme, to explain the mechanism of this laser, we will use three-level pumping scheme. Now the structure. In the Ruby laser, the working substance, that is the active medium, it is taken in form of rod of ruby crystal, and the dimension of this rod is 10 centimeter in length and 0.8 centimeter in diameter, in which the chromium ions are active center and other, that Al and O2 atoms, are inert. The resonant cavity is made by silvering the polishing end of ruby rod, fully reflected plates at the left and partially reflected plates at the right. Both optically plane are actually parallel. So this is that ruby rod, and the dimension is mentioned here, that the length is 10 centimeter and the diameter is 0.8 centimeter, and the front part of this rod is silver polished, and this is partially polished and 99% reflector, and this is 100% polished end. And so the Fabry-Perot resonator is here, where two in between two mirrors, one partially polished and 100% polished mirrors, that active medium or active centers are sandwiched. So for the optical pumping system, this is that flash tube, that radon or xenon flash tube, where the high tensile supply is given, and this is in helical form. So this is very simple structure, that rod, and this is just coiled by this xenon discharge tube. And also here that the wavelength of this laser output is mentioned, that is 6943 angstrom. The red color laser will be come out in this part, the partially reflected mirror part. So in order to explain the mechanism of this laser, the working principle, the three-level system is used, and we have discussed in detail this three-level system in our previous lecture. So this is that Venn diagram. So this is the ground state, where that chromium ions, especially that active centers are chromium ions. So in different transitions, that chromium ions will take place. So in the ground state, chromium ions are there, and by absorbing two wavelength, one is of the green light about 5500 angstrom, and second one is at that blue light about 4400 angstrom. After absorbing this, through absorption transition, the chromium ions excite up to higher energy level. These are the higher energy level. So the excited chromium ions from this higher energy level accumulate here in this metastable energy level E2 through a non-radiative transition. So there is no emission of photon here. That's why this is known as non-radiative transition. And the population inversion condition is maintained in between this E1 and E2. And when one external photon is given by that spontaneous process, then the spontaneous process, then stimulated transition starts, which is actually the chain reaction, and through the chain reaction we get high intense beam, which is known as the laser, and especially here this is known as ruby laser. So the wavelength of this red light laser, it is 6943 angstrom. This is highly monochromatic laser, and the limitations are the ruby laser emits in form of pulse because the population inversion condition are not maintained continuously. So here the population inversion in between E1 and E2 must be maintained forever, but this is not possible because the rate of transition of chromium ions from this E2 to E1 is more than the transition of chromium ions, supply of chromium ions from this higher energy level to this. So population inversion condition are failed in between. That's why we get pulse form laser, and its efficiency is very less, only 1%, because out of different wavelength of flash tube, that is the white light, only two wavelengths, one is of green color 5500 angstrom, and second the blue color, that is 4400 angstrom are used. That's why its efficiency is very less. Now some application. So the range finding is one of the first application of ruby laser. It was initially used to optically pump tunable dye laser. Laser metal working system for drilling holes is hard material. High power system for frequently doubling into the UV spectrum. This is also one of the application, that high brightness holographic camera system with long coherent length. Medical laser system for tattoo removal and cosmetic medical, and high power Q switches system. So the summary of this lecture. In this lecture, the construction and working principle of a solid state laser, that ruby laser, was discussed in detail. Some limitations, it is that the efficiency and the pulse form laser, and man applications were also discussed at the lot. Thank you very much.